This is lecture 7, example 2. We've been working with memory, and here's another memory type problem. So let's do it. And so this mixes a couple concepts here. Unfortunately, it does something really dumb in here, but we'll fix that later. But we'll just play along. Then we'll actually come back and tell you how dumb this is. So essentially, this advertises the power of using memory instead of registers. So right away, what I'm doing here is I'm taking the average of 32 half words in memory. And if it wasn't in memory, if it was in registers, the code would be really long and impossible to work with. But we really don't have 32 registers to work with. One of the registers is 0. So there's just absolutely no way we could do a problem like this without using memory accesses like with main memory. So essentially it's set up really nicely. It's taken an average, and I'm taking the average of 32 things, of course. I'm going to add them all up. The algorithm, add them all up, divide by 32, which is conveniently 32 is a power of 2. And essentially I'm going to be able to average that thing by shifting right 5 places. So it's not a big deal. I'm going to add these up, shift right 5 places. Okay, so I keep telling myself I'm going to write a flow chart for anything here. So this would be, I don't know what I called it. Average 32. Typically, what I'm going to do in these programs is I'm just going to pass, this is going to be a subroutine, I'm just going to pass the address of the first piece of data to the subroutine. And so that's in x20. Now the location, nope, it's in x10. I'm going to put the result in x20. Okay, so let's crank through this thing. There's going to be always going to be some init code in here. I'll worry about that in a second. And I'm going to say, let's see, count 1 equals 0. The idea here is I'm going to put this in a loop, and I'm going to decrement the loop count each time through the loop. And if that loop count is 0, I'm going to quit. Okay, if I don't quit, I am going to do other stuff. I am going to get data from memory. I'm going to accumulate it. I'm going to do some loop admin, and then I'm going to come back and check the value again. Okay, so you can tell the structure of this is going to be a couple sequence statements, and the heart of the thing is going to be a loop, which is going to, we model it like a while loop, and that's going to work nicely. And so I think that's it. The more important thing, it's really high level because I didn't really say what loop admin to do, and I didn't really say what initialization to do. So this is actually going to be good. AVG. Oh, darn this pin. That's my subroutine name. And I know I have to init stuff. So this is actually accumulating some data. And so the very first thing I want to do in this thing is clear an accumulator. And the accumulator, might as well just use x20. It's going to be x20, x0. So it's going to move the value of x0, which is 0, and x20, which has the effect of clearing this accumulator value I'm going to use. I could have used any register, but the code kind of called out for x20, so that works good. Okay, the next thing I need to do in this thing is load a register. I don't know what, it doesn't really matter which one, x15 with a, this is going to be my iteration count, so I'm going to load it with 32. Okay, so lastly here, this is the dumb part. I'm going to, it said to don't permanently change x10, and so what I'm going to do is just store x10 somewhere. This is, I don't know, kind of dumb. I wish I had chopped this out. Doesn't really fit in the problem. Okay, so I'm saving x10. Okay, so that is my initialization stuff. Now this is super typical of any loop I do. Looks pretty much the same, except for this. This is admittedly a dumb instruction. You'll see why later. Okay, so here I am at this thing. I need to check the loop count, and I'm going to say BEQ, EQ. My loop count is 15, and if it equals 0, I am going to say I am done. And I'm going to come down here. My habit is anytime I write a label, I try to put it in the program so I don't forget. So I'm guessing it's way down below, and that looks good. So there is this jumping to done takes care of this. Okay, so if it's not done, I need to go get some data, and that's going to be, I think we're working with half words here. So that's going to be load half x. It doesn't matter where I put it. Let's put x25. The address doesn't have an offset. The base address is x10. Remember, I'm sending the base address, the address of that first piece of data, in an x10. So this statement here grabs that piece of data. Once I have that data, I am going to accumulate it. So it's going to be an add. My accumulator is x20, x20. This is the typical accumulator, x25. So this is the meat of the program. That's the body of, well, that's not the whole body of the loop, but these two instructions here represent the body of the loop. And that's these two things right here. I'm done. I need some loop admin on this thing. So once again, super typical. I need to do two things. One is I need to advance that the address index. So this is going to be x10, x10. I'm working with half words here, so I'm adding 2 to it. If I was working with words, I'd be adding 4. If I was working with bytes, I'd be adding 1. I'm working with half words, so I'm adding 2 to it. So x10 now is 2 greater than, it's going to point out the next half word in that sequence. Next thing I need to do here is it's an iteration. I have a loop counter, which is x15. I'm going to decrement that loop counter by 1, and that's pretty much my admin. And the last thing I'm going to do is jump to loop, and loop is going to be this instruction right here. Okay, wow. I think I'm done. I think I've done everything in this. So this is, once again, super powerful instruction. I mean, there's so much of what we do is go to memory and get stuff out of it, and that makes for a good problem. Once again, because I'm using half words, I'm adding and increasing that index by 2 each time through the loop. Oh, okay, so actually I just remembered the done part. I have to restore this value right here, because done, move or x10 has been changed by the code. I actually saved it in x16. I need to move it back. And this is x10, x16, and this is done. Not this. Okay, yeah, dumb problem. But anyway, we'll call it done there. And the issue is that it's important sometimes when you enter subroutines to save data, or to protect your registers. But this is just not the way to do it. I don't know why I left it in there. And I'm going to call that done. I think we have a solution sitting there. And yeah, I don't know what. Oh, nope. Yeah, I forgot the most important part of this. Is we need to shift it. We need to do the divide. So shift. I can't believe I forget this stuff. Shift right, logical, immediate, X20, which has my result X20, and I'm going to shift it by 5, and then I have a return. Okay. Yeah, sorry about that. I guess the issue here is to always take one last look over your code before you call it done. I'll certainly remember that for the next problem. Okay. Yes, I like that now. And so most importantly is this is a barrel shift. It's shifting it. It's doing a right shift by 5-bit locations. This is what the instruction is doing. That's going to be a divide by 32 with truncation, by the way. And I'm going to call this problem done.